Okay, 6 choose 4. This was used in first year binomial expansion. Here was the definition of it from the formula book. So it's 6 factorial over 2 factorial and 4 factorial. The 2 factorial comes from 6 take 4. I've just written it in full form. Notice that on this, most of the stuff can cancel out, so the 4 factorial and the 4 factorial will go. And so we can cancel those out. And so we get left with something like this, 6 times 5 over 2 times 1, and we can evaluate that. Now, we're going to use this fact that most of the stuff cancels out to do the second year binomial expansions. Let's just look at another example quickly. So let's do 6 choose 3 as well. Almost the same things. We get 6 factorial over 3 factorial, 3 factorial. And then doing the cancelling out, where we're going to have a 6 times 5 times 4. Everything below that will cancel out with one of the 3 factorials. And then we'll still have one of the 3 factorials left. Now, what I want to point out here is that whenever we do these cancellings, the things that are left, we have the same number of things on the top and the bottom left. So here there are 2 things on the top, 2 things on the bottom. Here there are 3 things and 3 things. We can use this fact. So let's have a look at a typical sort of problem. We're going to be dealing with something that looks a bit like this. 1 plus x to the half. Let's begin with this one. Now, the problem we have immediately here is we can't do anything with that half using first year techniques. So trying to do choose functions with it, it won't be defined. I'm going to jump straight to the solution here just to show you the process that we go through when we're doing this. So the first part of the answer is always just going to be 1. And that comes from expanding out a whole lot of brackets where it's 1 times 1 times 1 times 1. Now I know that there are a non-whole number of these brackets. That's still fine. This is still going to be here. The next one is going to be whatever we had up here, usually referred to it as n, times whatever we had here. So it would be a half times x. The next one, well, we're going to have whatever we had up there, a half, multiplied by, well, just like with factorials, if we took 1 away from the half, we'd have minus a half, like that. But just like we were doing on these ones here, we want the same number of things on the top and the bottom. So on the bottom, we're going to have 2 times 1, it's like 2 factorial. And then that's going to be multiplied by x squared. And we can keep going with this. This is like the factorials. So just like this one here, we'd had 6 multiplied by 1 fewer than it, over 2 times 1. This is the same thing. We had whatever the power was, times 1 fewer than it, over 2 times 1. Let's do the next one. It's going to be a half, which is the power, times by minus a half, which is subtracting 1, times minus 3 over 2, which is subtracting 1 again. And we want the same number of things on the bottom, so 3 times 2 times 1. So what we're doing here is we're never quite using the factorial notation, because factorial is only defined if you've got whole numbers. But we're doing the same sort of thing. It's like we've already done the cancelling. This is multiplied by x cubed. I'm going to do one more here just so you've got the idea. So plus a half times minus a half times minus 3 over 2 times minus 5 over 2 over 4 times 3 times 2 times 1. X to the 4 plus dot dot dot. These go on forever, they never stop. You can now grab a calculator and type these in. Calculators that have the fractions inbuilt in for you make these a lot easier because we've got some triple layer fractions. I'm going to do another one. So we've done one with fractional powers. Let's have a go at one with negative powers. I'm also going to mix it up a bit by putting a different number in here. Minus 2, something like this. Right, so the pattern goes, it's always 1 as the first one. Plus, we're going to do whatever was up here, minus 2, times by whatever was in here, 2x. Right, next one, plus minus 2, multiplied by, well, if I subtract 1 from that, we get minus 3, over the same number of things on the bottom, 2 times 1, multiplied by 2x, which is the thing over here, to the power of 2. Right, let's go again. Plus minus 2 times minus 3 times minus, need an extra multiplication sign in there, times minus 4 over 3 times 2 times 1 times whatever we had up here to the next power, which is 3. Notice that as I'm doing these, a lot of the things cancel. So like on this one, that 3 cancels out with that 3, and that 2 cancels out with the 2, and the negatives cancel out and things, and we can evaluate all these things. I'm just going to do the next step of actually simplifying these ones for this, so you've seen it once. So 1 is 1. These ones, negative 4x. This one over here, well, negative times negative is a positive. 2 and 2 cancel out. We've got 2 times 2, because it's squared, times 3 is 12x squared. And then the next one, minus times minus times minus is minus. 3 and 2 and 3 and 2 all cancel out. 2 cubed is 8 times 4 is 32x to the 3 plus dot dot dot. Notice how the signs are alternating on these. They often are, they're not always though. Okay, those are the basic methods here. These methods only work when you've got a 1 at the beginning of these things. That wasn't true of the type that you were doing in first year binomial expansion. Let's have a go at one which doesn't have a 1 in it, and we'll talk about how we bodge it. Okay, so 2 plus x to the minus 1. It's got a non-positive integer here, so we know how to use this method. Here's the tactic. We could write that as 2 to the minus 1, 1 plus x over 2 to the minus 1. What I've done is I've taken a factor of 2 out of here. If I didn't have that on there, then it would just be factoring out of 2. But because I've got it to the power of minus 1 there, we need it to the power of minus 1s on both of these. Okay, well that's 2 to the minus 1 of whatever the expansion of this is. So we can do this expansion and we'll just pop it in a big bracket here, and then we'll worry about the 2 to the minus 1. Okay, first term is always 1. Next one is whatever n was multiplied by this thing, so minus 1 times x over 2. Right, next one, it would be minus 1 times minus 2 over 2 times 1, multiplied by this thing over here, x over 2 all squared. I'm just going to do one more so we've got the idea here. Plus minus 1 times minus 2 times minus 3 over 3 times 2 times 1 multiplied by this thing, x over 2 cubed plus dot dot dot. Right, let's do some evaluation. That's 2 to the minus 1 multiplied by 1 minus x over 2. Now notice the cancelling on this. Minus times minus is a plus. 1 and 2 all cancel out. And so it's only this thing left. X squared over 4. Next one, minus times minus times minus is minus. 3 times 2 times 1, 3 times 2 times 1, those all cancel out, and we're left with this thing. There's often a lot of cancelling on these. You can probably see what the general pattern is here. Last thing to do, well, 2 to the minus 1, that's a half. Let's just times by that. So we've got a half minus x over 4, sorry, a bit messy, plus x squared over 8 plus x minus x cubed over 16 plus dot 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 dot. And I think we can see what the pattern is going forwards. Right, so I've given you a kind of method here. If you want to have a look at the formula in the actual book, you can use that. You're given it in the formula book as well. But I think it's one of those things to just get the practice of. Try using the method lots of times and you will see where to put things in the right places. Common mistakes are not putting enough terms on the bottom here, so it's the same number top and bottom, and not putting your brackets in here. Whatever you've got inside the bracket needs to be in brackets with these. I think you've got everything you need there to be able to do some questions on it.